Okay, so in this segment now, we're going to take a closer look. We looked at volume, we looked at pressure in the last segment, and we looked at perfusion. All right. In that scenario that I gave you in the last segment, I actually gave you a synopsis of hypovolemic shock. But let's look at it in a little nutshell here. So, this is our vasculature system. This is our preload. The vasculature system holds blood. What did I say was in blood in the last segment? Hemoglobin. What is in there? Oxygen. Oxygen carries, hemoglobin carries oxygen to the vital organs. One of the vital organs is what? The heart. So there you have it. You have the heart. Then the heart then pumps. This would be your afterload. Where does this blood goes from your heart? It goes in two areas. It goes to your vital organs and your non-vital organs. Okay? So what are vital organs? Vital organs are your heart, your kidneys, yes, your brain, your lungs. Non-vital organs would be like your skin, your hair, nails, all those different things, okay? So non-vital organs is in that area. So this area here is what is called systemic vascular resistance. This is where you will see that pressure being balanced in this area. Systemic vascular resistance. This here responds to how much blood is coming from the heart, if it's no blood or if there is blood. So this vasculature system responds by expanding or constricting. What happens from the non-vital organs? This blood is then carried back into the vasculature space to be oxygenated again, right? In that cycle. So let's draw this again. Good. Okay? So it goes back into the vasculature system. So hemoglobin and oxygen is in here. So what's happening? If there is loss of blood, look at this. This is blood. This is loss of blood. What happens here is it drops. Look at that. There's not enough blood going into the vasculature system here now. Look at that. What's going to happen? Your cardiac output is going to drop because there's not enough blood going into the heart to go to the vital organs and the non-vital and the organs. So your cardiac output is going to drop. But this is hypovolemic, low volume. What happens here, the first thing you're going to see is you're going to see a drop in the jugular venous pulse. So your jugular venous pulse is going to drop. If your jugular venous drops by palpating, or you have your JVP line in and the number is low, then you more than likely have low pressure in the vasculature system. So after you have after you would have looked at your JVP, your next that you're going to look at is your cardiac output. Cardiac output is going to drop. Now, when you look at PCWP, this is measured in the left atrium. Your jugular venous is measured in the right atrium. Okay? So what's going to happen? If you have the left atrium is in the preload, right here, in your left atrium. So what do you think is going to happen there? It's going to drop. Blood pressure is going to drop. There's not enough blood circulating to the vital organs and the non-vital organs. So your skin, where we're expecting warm blood to come, what's going to happen? It's going to be cool. It's going to be cool and clammy. Your ejection fraction, that's your heart. That's this. Look at this. You know, if you're trying to prime something to get this blood, so your heart is going to pump hard to try to get this little bit of blood out. So it's going to work harder and harder and harder. So that means that this is your ejection fraction is going to go up. Okay? Ejection fraction measures how sick your heart is, how sick it is. So now, look at this here. It's trying to pull that blood from that area. Okay? And now the ejection fraction is low. It's going to go up high. Your systemic vascular, we already know that the cardio output is high, is low. So our SVR is going to go up high. What's going to happen to the heart rate? The heart is pumping harder and harder and faster. So look at this. It's going to go up high. So now when we look at hypovolemic shock indicates that your cardiac output is low and your systemic vascular resistance is high.